Hello and welcome. Today we are going to see how we can balance certain chemical equations, those that may be slightly challenging. And we are going to start with the one for oxidation of ammonia in presence of platinum catalyst. And for any equation to be balanced, you have to first write it before obviously balancing it. And for that to be possible, you have to be knowing the products formed. So in our specific example, where ammonia reacts with oxygen, we form nitrogen monoxide, water and heat. That's why we are saying it's an exothermic reaction. So for this type of equation, we shall first look at the constants that we have, or the elements that we have. We have nitrogen, both sides, and we shall try to follow through and see that the number of atoms of each element on the left hand side of this arrow are equal to the number of elements on the right hand side. So as we can see, we have nitrogen here. Nitrogen is 1. This side nitrogen, we also have 1 atom. So nitrogen is balanced. Hydrogen, we have 3 this side. Hydrogen, we have 2 this side. So we need to first balance our hydrogen. But the trick we are going to use while balancing this equation is that we are going to try and balance the element which is alone last. So we shall balance our oxygen last because it's alone here. So getting back to hydrogen, we have 3 atoms here, 2 atoms here. So for us to balance these atoms, the minimum multiple of 3 and 2 that we can have is 6. So we shall multiply this whole molecule here by 2 such that we have hydrogen 6. While we shall multiply this molecule of water by 3 such that we have hydrogen also 6, 3 times 2. In that case, hydrogen will be balanced. So at this point, we shall have hydrogen 6, even this side hydrogen 6. But in doing so, we have changed the number of atoms of nitrogen. We shall have nitrogen 2, this side on the left, while this side we have nitrogen 1. So to make nitrogen 2 as well, we shall multiply this molecule by 2. So we shall put here 2. So nitrogen will also become 2 on the right hand side of our arrow. But now we are left with oxygen. Oxygen we have 2 this side, while this side we have oxygen 2 plus oxygen 3, which gives us a total of 5. But this side we have oxygen 2. Now one thing to note is that the oxygen atom or nitrogen monoxide is already balanced with nitrogen. Because our nitrogen is balanced with the 2 here, I wouldn't like to disturb this molecule here. It's already balanced. My nitrogen is balanced. If I try to change this 2, I'll have to go back and balance the nitrogen again. The same applies to this oxygen. These 3 atoms of oxygen on the side of the products, they're already balanced with water. So I wouldn't like to disturb this oxygen on the right hand side because my hydrogen is already balanced. That's why I said we shall balance oxygen last. So what will I do? I'll look for a number or a fraction which when I multiply by 2, it gives me 5. And in this case the fraction is 5 over 2. This gives me 5. So if I put here 5 over 2, that means my oxygen will be balanced, but with a fraction, because now I'll have 5 oxygen atoms, and this side I'll also be having 5 oxygen atoms. So because we don't like to balance with fractions so much, for that reason, I'll have to ensure that I remove the denominator. And in mathematics, to do that, we always multiply by 2 throughout. Multiply here by 2, multiply here by 2, by 2, and by 2. So we shall have 2 times 2, which is 4. 2 times 5 over 2, which is 5. 2 times 2, which is 4. 2 times 3, which is 6. So this will be the coefficients when balancing this equation. So we shall come up with something like this. So at this point, our equation will be balanced. Nitrogen, we have 4 atoms. Beside nitrogen, we also have 4 atoms. Hydrogen, we have 4 times 3, which is 12. Hydrogen, we have 6 times 2, which is 12. Oxygen, let's put it here below oxygen. We have 5 times 2, which is 10. Oxygen, we have 4 times 1, which is 4, plus 6 times 1, which is 6, which also gives us 10. So all the elements will be balanced. At this point, we shall say we have a balanced chemical equation of this sort. The second example we are going to look at is the equation where we react potassium permanganate with hydrochloric acid to form our chlorine gas. This equation is for the lab preparation of chlorine gas. Feel free to pause the video and try balancing it on your own. However, like I said, we shall balance elements last. Look at the equation, look for an element which is alone and balance it last, because at that point we can put here any fraction. Like in our previous equation, we put here 5 over 2. So we shall balance our chlorine last in this equation. So let's have a look at it. Potassium, we have 1, potassium, we have 1. Potassium is balanced. Manganese, we have 1, manganese, we have 1. Manganese is also balanced. Oxygen, we have 4. Oxygen, we have 1. So we can balance oxygen by putting 4 here, so that we have 4 molecules of water. So if we put here 4, oxygen will also be balanced for 4. So we have hydrogen, 1. This side we have hydrogen, 8. 4 times 2. So we shall come and put here 8. So everything is balanced for now apart from chlorine. This side now we have chlorine, 8. This side we have chlorine, 1 from here, potassium chloride. Here we have chlorine, 2. And here we have chlorine, 2. So in total we have 5 chlorine atoms on the right hand side of the equation, that is to say on the product side. But now if you look at our chlorine and potassium chloride, our potassium is already balanced. I wouldn't like to change the coefficient here, so I will not tamper with this chlorine. The same applied to manganese chloride. Manganese is already balanced. I wouldn't like to tamper with the coefficient here, because I will go back again and rebalance manganese. So that's why my focus must be on this chlorine here, which is alone. So I want to have 8 chlorine atoms on the right hand side, but I already have these 3 I can't touch. That means I need the 5 here, such that 3 plus 5 gives me 8. So which number do you multiply by 2 to get 5? It is 5 over 2. So I'll come and put here 5 over 2. That means I'll have a 5 here, plus 2 plus 1, which is 8. Now, like we had seen in our previous example, we shall need to remove the denominator by multiplying throughout by 2, by 2, by 2, by 2, by 2, by 2, by 2. So we shall have coefficients of 2, 16, 2, 2, 8, and 5. And then we shall have an equation of this format. So one thing to note, the equation is balanced. Potassium 2, balanced. Manganese 2, manganese is balanced. Oxygen 2 times 4, which is 8. Oxygen 8 times 1, which is 8. Hydrogen 16. Hydrogen 8 times 2, which is 16. Chlorine 16. Chlorine 2. Chlorine 4. Chlorine 10. 10 plus 4 plus 2 is also equal to 16. So this equation will also be balanced. That's how we can balance some of these equations, by always focusing on the element that is alone in that given equation. Thanks for watching. Feel free to let me know which equation gives you a hard time and we give it a try. Stay safe.